once translation has initiated, elongation can occur. Elongation specifically of the polypeptide chain. So after initiation, we have the formulated methionine tRNA hanging around in the ribosome, ready for elongation to occur. So it's specifically in the P site. There are 3 sites of the ribosome: the A site, the P site, and the E site. And before going on, we must talk about what each of those are. So the P site stands for peptidyl. And the reason why that's important is because the peptidyl site, or the P site, is where the existing peptide chain will be. So now, initially, the peptide chain is it's not even a chain, it's just one amino acid. The A site is the acceptor site, and the acceptor site is where the next amino acyl tRNA binds. So that's A site here, this acceptor site. The last site, the E site, is the exit site, and the exit site is where the empty tRNA leaves. So how does elongation happen? Well, this next amino acid, so this here is the formulated methionine, the first amino acid in prokaryotes. So this thing is going to have a free amino terminus. So this next amino acyl tRNA comes in and it goes to the A site. And it binds in the A site. And this is binding, of course, according to the codon here on the mRNA strand. Just because I don't want to draw it, it might be too small. This amino acid will be, or this amino acid attached to this tRNA will bind here according to the codon and anticodon base pairing here between the mRNA and the tRNA. Once this tRNA is bound, then we can have the elongation step occur, the actual elongation step. So what does the elongation step consist of? Well, amino acid number 2, the next amino acid, its amino group, I'm just going to put amino group will act as a nucleophile and attack the carboxyl carbon on the previous amino acid in order to form a covalent bond. So in this case, the previous amino acid is the formulated methionine, and it's initially in the P site. So the amino acid number 2, its amino group will attack the formulated methionine, causing it to join and covalently bond. So that there is the actual elongation step. This elongation step is catalyzed by an enzyme called peptidyl transferase. And this process costs 1 GTP. So once that covalent bond forms between the amino acid number 2 and the formulated methionine, the covalent bond holding the formulated methionine to this tRNA breaks. So then what we have is this. So this tRNA in the P site is now empty, and the existing polypeptide chain is in the acceptor site. That's not what's supposed to happen. The existing polypeptide chain is supposed to be in the P site. So what's going to happen is both of these are going to shift over and move one codon space. They're going to shift over a space this way. So they're going to shift over one codon. That step is translocation, translocation. So that translocation step costs 1 GTP as well. So what ends up happening is that empty tRNA is now in the E site and it's ready to exit. So this thing can now leave. And what's left? It's just the existing polypeptide chain is in the P site, and now this next amino acid is ready to bind at the A site. So we're back to where we started from. So now the process can happen again as many times as necessary in order to form that peptide chain. So how is this different in eukaryotes? Well, in eukaryotes, there's no formulated methionine. It's just a methionine. And the other difference is that instead of having a 70S ribosome, there's an 80S ribosome. Other than that, it's pretty much the same. Hope that video was helpful. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com. See the description below for more details. Thank you for watching.